Good morning, my lovers. Thanks for coming to my site again today. I'm Salahuddin Aishat by name, like you all know. Today, I will be taking you what Eigen value and Eigen factor is. I will explain to you how to estimate them. How would you be able to calculate Eigen value and Eigen factor? Eigen value and Eigen factor, before you can understand them, we need to understand how to get characteristic polynomial. Characteristic polynomial will be obtained from our characteristic equation. Now, assume you have a 2 by 2 matrix. Let's say A equals 1, 2, 3, and 2. So, assume your factors. You can name them any variable, x1, x2. You can decide to name it x and y. The first thing you do is to create your characteristic equation from the formula AV equals to lambda V. If you have AV equals to lambda V, that's the same thing as A minus lambda V equals 0. Yes or no? You have AV, then if you move lambda V to this side, you have AV minus lambda V. Phi is common, you factorize it out, then you have A minus lambda equals to phi. From here, your A is what? What's your A? You have 1, 2, 3, 2 minus your lambda. But because this is a matrix, it can't be ordinary lambda, it will be lambda I. So you have an identity matrix 1, 0, 0, 1. Then your factor, which is x1 and x2, equals what? Is a 2 by 2 matrix. This should also be 0. So from here, what do you have? You have, let's multiply the lambda with the identity matrix 1, 2, 3, 2 minus lambda times 1 is lambda, lambda times 0, 0, then lambda. Then you have what? x1, x2, and your as well you have 0, 0. So this is what you have now. You now have this. If you subtract this, you have 1 minus lambda, 2 minus 0 is 2, 3 minus 0 is 3, 2 minus lambda is 2 minus lambda. Then x1, x2. That's subtraction of matrix. You take this cell minus this minus this minus this minus this equals to what? 0. The next is that you assume your factor x1 and x2, assume this factor is not 0. Now, if this factor is not 0 and their multiplication is 0, that means the determinant of this here, 1 minus lambda 2, 3, 2 minus lambda, will give 0. So now let's find the determinant. You know how to find the determinant of a matrix? You multiply the main diagonal. For a 2 by 2 matrix, you multiply the main diagonal minus the subordinate diagonal. So you have 1 minus lambda, 2 minus lambda, minus, then this times this, 2 times 3 equals to 0. 1 times 2 is 2, 1 times minus lambda minus lambda minus lambda times 2, minus 2 lambda plus lambda square, minus 2 times 3 is minus 6 equals to 0. So from here, you have ordinary lambda square. Don't forget, those that are square can only add each other. So you have minus lambda minus 2 lambda, that's minus 3 lambda. 2 minus 6, that's what? Minus 4 equals to 0. We call this one here, we call this our characteristic equation. And we call this characteristic polynomial. If you solve this characteristic polynomial, this is a quadratic equation, then the product of this one times minus 4, that's minus 4, then you have minus 3 here. The two numbers that if you multiply them, it gives you minus 4. If you add them, it gives you minus 3. We have what? We have minus 4 and 1. Minus 4 and positive 1, because minus 4 times 1 will give us 4. 1 times minus 4, you are finding the product that will give you 4, and you are finding the sum that will give you minus 3, which will be what? Minus 4 times plus 1. Minus 4 plus 1 is minus 3. Minus 4 times plus 1 is what? Minus 4. So you have lambda square minus 4 lambda plus lambda minus 4 equals 0. Then you group and factorize. So if you group here, you have lambda minus 4 plus 1 lambda minus 4 equals to 0. Recall that if you have quadratic equation, these two must be the same. If not, then there is mistake somewhere. So from here you have what? You have your lambda minus 4. You take one of these two here, lambda minus 4, then lambda plus 1, and you have lambda plus 1. From here, you can now say your lambda minus 4 is 0, meaning that lambda is 4, or lambda plus 1 is 0, because before this product can be 0, that means one of them is 0. Then that means what? Lambda is minus 1. So these are our eigenvalues. Eigenvalues, lambda 1 equals 4 and lambda 2 equals minus 1. That is how to calculate eigenvalues for a 2x2 matrix. Please subscribe on my page, like this video so that you can continue with us. We'll be taking eigenvector in the next video, then eigenvalues for a 3x3 matrix and eigenvector as well. Thank you.